Oh yeah. So often the difference between a nice idea and a successful idea comes down to communication. We've all seen tons of examples of products or concepts that were great, but just failed to land with an audience and then ended up just kind of lost in the noise. When you guys go on to your careers, you'll probably see it a lot there as well. When you have a good idea, when you personally have a great idea, no matter how good it is on paper, you're going to have to do a lot of talking, a lot of communicating, a lot of self promotion to really get that idea out there. Important thing to remember, that said, is that talking is not always the only way of communicating an idea. So until relatively recently, low impact development in Ontario was one such nice idea. Not necessarily a successful one, just a nice idea. And show of hands quickly, who here has actually dealt with low impact development before this conference? I know you guys have. Anybody else? So you guys haven't been exposed to this at all, really? Okay. So low impact development is a very great idea, and it's actually very unfortunate that it's still in that nice idea that has been, like I said, until relatively recently in that nice idea column. Because low impact development is a cost-effective way to treat water at source. It tends to use up a lot less space than, say, a conventional stormwater management system, such as like a stormwater management pond. And if done correctly, low impact development can be very good for the environment. So look on the left side here, permeable pavement, a great example of low impact development. Fully a quarter of the runoff from an intensive city area could be stored at the site rather than flooding onto our streets. Or if you think a rain garden here, so basically rain downspouts from a house just connected to a little infiltration area, runoff from a roof is among the cleanest rainwater we have. And we could be putting that back into, say, the aquifer rather than letting it run into a sewer and getting all dirty. So despite the fact that there's been a rising tide of adoption in the United States, which is way ahead of us in terms of this, and mountains of data about how this stuff is working out, we haven't really seen that adoption in Ontario, again, until quite recently. And the problem is, unfortunately, engineers. And I do count myself in this group. I am very much part of the problem. Because engineers are creatures of habit. Since we deal with really complex systems that are intersection of things like climate, rainfall, runoff, and downstream receivers, we tend not to trust those physical formulas. We tend to go for curves that are fit basically to experimental data, stuff that's been measured. Best of example of this guy here down in the gray is called Manning's formula. This is the biggest formula in stormwater management. It's what holds it all together. This curve is the governing, this curve formula, sorry, is the governing formula for everything that I do. It's actually not a physical formula. It was developed as a best fit curve by an accountant over 100 years ago during the Irish potato famine. But it works, and that's why we still use it. And that's the kind of attitude engineers have. We all have our own Excel spreadsheets for calculating things like pond depth or pond size or stormwater capacity. And it's ridiculous, but I mean, that's what we have. It works, so we hang on to it, even when better modeling comes along. So changing that kind of attitude, introducing low impact development to that kind of people, it takes a lot of salesmanship. And to their credit, regulators like conservation authorities and cities have done a lot of work getting the word out there about the benefits of low impact development for developers and for cities. So people like David have been talking at conferences for a long time. People like Jen Hill, who you'll hear from later on, has done a lot of work with the Sustainable Technologies Evaluation Program and the Toronto TRCA. There's also been a lot of regulation changes that have encouraged low impact development. Despite these really great endeavors, there's still a lot of headwind to actually bringing up LID and making it something you see a lot in Ontario. Actually, just a quick question. So you guys haven't seen LID as far as design before. Has anybody actually ever seen elements of low impact development in Toronto? Like permeable pavement, we've got a couple there, okay. So things like a bioretention system, things like a rain garden, they're not that common. So the problem, again, as I said, is engineers. And engineers are busy people. You can only really get in front of them so often in terms of doing workshops, doing conferences. So how do you kind of convince them of the benefits of low impact development? A couple of years ago, some conservation authorities got together and came up with an innovative solution. They were going to make a software tool. So a software tool as a way of communicating, as a new idea, especially a new concept or breaking a habit, has some great things going for it. For one, a software tool gives you a lot more face time with your audience. So when you're talking at a conference or a workshop, that's a single structured event. You give them a software tool, they can bring that home, they can use it again and again, and they can keep trying it out on their own. So think of the difference between, say, having a Fitbit versus going to the gym, or downloading a song versus going to a concert. You have that to use over and over again. Every time the person uses that piece of software, there's a chance for your message to get across. Another benefit of doing the software tool route is that it allows people to control the message and control the methods being used by your new idea. So, for instance, if you're looking for a runoff concentration for phosphorus or something from Milan, why would you go and look up contradictory references when you've got both the number and the method for calculating it in one convenient spot? This kind of evenness of having all starting from the same methods and same numbers is critical. Definitely, if you have a break later on, ask the regulators about this. They will tell you the first thing they check when they're doing a model and you're submitting a report, they're going to check the actual parameters that you used and what your base assumptions were. Finally, going the software development route allows you to introduce a new way of communicating, because now suddenly, in addition to talking to people, you've got this tool you can pass back and forth between the engineers and the clients, between the developers and regulators. You can all try something out, you can all see how things work, and you can actually come to the same conclusions together. So here's the development team. This is the conservation authority development team behind me. We got together and we looked at a couple of existing low-impact development tools, and they ended up deciding ultimately to create their own tool, so not use one of the existing tools. And they did that for 3 reasons. First reason, they wanted something, again, that they could control. They could set the methods, they could set the numbers. Number 2, they had specific questions for things in Ontario. Ontario has certain regulations as far as flow impact development, as far as stormwater, so things like runoff control volumes, things like infiltration, things like phosphorus loading. They wanted those specific questions answered, and that's why they wanted their own tool. Third reason they went with their own tool was because they wanted to be free. They wanted to be available to all the developers, and they wanted more than that. They wanted to be open source, so that now, as other regulators see this tool, they can use it, they can adopt it, they can make changes to it. It becomes their own. So here's a schematic of the tool we developed. And again, this tool is not just for engineers. This is a tool that we've tried to make open to everybody, to clients, to environmental science, to technicians who are going to be working with these low-impact development features and understanding how they're going to go in and work. We didn't develop this tool entirely from scratch. We used the EPA Stormwater Management SWIM 5 management model from the Environmental Protection Agency in the US. So this is a fairly key model. Actually, I'll just talk about SWIM for a second and give it a plug. It's a free model to download. It's very kind of intuitive. It's very easy to use. And I will not lie, it looks good on a resume. So if you do have any interest at all in doing stormwater management later on as a career, download this model, play around with it. It'll help you understand stormwater management. So the way our tool works, the user designs their thing in the interface. The tool then creates the input file for SWIM. SWIM 5 runs the background, produces a report file. Our tool is going to mine that report file to get some of the information out of it, and answer those key questions that the conservation authorities are looking for. So again, things like water budget and runoff of certain parameters. And the idea is all this has happened in the conceptual design phase. So when you think of development, you have an early development, just looking at a blank site. You have a conceptual design phase when you're working out where the houses are going to go, where the commercial areas are going to go. And then later on, once you've actually gotten to drawing the lots, drawing the sewers, drawing the roads, then you do your deal design and you're done. So this is at that early stage. And the idea is that right when the developer is sitting down with the regulators or maybe with the public at a design charrette, they're getting to figure out where they're going to put some LIDs and how this is going to work and what kind of targets they're looking for. So again, this model is being designed as a way for plenty of people to use at that early design stage and open for everybody to use. So I'm going to give you a really quick run through the user experience from the model. Again, this is a model for everyone. We're not making this specifically for engineers, but people who want to experiment with different LIDs and get a good idea of what's happening with stormwater management. So when you first select your site, you just select a location and whether or not you want to run an annual average storm event or a specific one storm event. You select your location, and based on that, the tool is going to recommend some average annual precipitation, or you can go ahead and enter your own numbers. Conversely, if you want to do a storm event, so if you're looking for the 100-year storm or a 25-millimeter storm, you go ahead and enter that. You enter in the distributions for your rainfall and run the tool. When you actually get to running the tool, you get to draw your catchments and draw your LIDs within the tool. The models are done in a GIS environment, so you get all the areas measured for you. The tool is going to pre-enter some of that data for you based on the area you've drawn. You can draw on a base map, you can draw on an aerial photo, you can draw on GIS and CAD files you've imported from some other source. And all the user has to do is enter in basically stormwater or soil information and some basic information about land use. And the tool is going to pre-fill some of those values in there. So again, all the default values are in the tool, but you can go ahead and override those. So things like curve number for runoff, things like runoff concentrations, you can go ahead and override those if you have a reason to. As far as LIDs, we've got a whole bunch of LIDs in the tool, so you guys hopefully will be seeing more of these in your next couple of years of study. Different LIDs include things like surface LIDs, so rain gardens, where basically you just have a low point in the ground that's designed to infiltrate water, or something like a permeable pavement. Infiltration LIDs, so things like infiltration galleries, things like bioretention facilities, you can add those in there. Things like oil grit separators, so that's when you have a manhole, you have a lot of flow coming in, the manhole is going to remove some of that sediment for you because of just the way the manhole is set up, or even traditional stormwater management facilities at the end of pipe. So all those are in there. We've got default removal percentages for those to provide what kind of environmental benefit it's going to do. But more importantly, you can override those because we understand that one size does not fit all when it comes to LIDs. It really depends on the design of them. And you guys will be doing the design of some of these LIDs. Fortunately, the tool has some helpful hints in there to help you design those LIDs. So for instance, if you've run too much area tree LID, it's going to flag that for you. If it's going to take a long time for your LID to drain down. So for instance, if you build a big storage system in the ground and the soil is really tight, it's going to basically take a long time to drain out, and the tool is going to flag that for you. So once you've done all that design, you've got your site laid out, you go ahead, you run the model does the swim 5 stuff, looks at the post-processing, and gets those results. So this is the first result, and this is, again, if you're running a storm event, the tool is going to give you an idea of volume control. And volume control is runoff volume control is wording that comes from, well, was coming from the Ministry of the Environment, now the Ministry of Environment, Conservation and Parks, thank you, yes. And we're still looking for that manual. It'll maybe come out someday. But we're looking basically at site control. So this is my question for David. When you think of storms, I mean, in Ontario, we're asking you to basically control, it doesn't sound like much. It's like 2.5 centimeters is the design storm, John, like 25 millimeters, 2.5 centimeters. Turns out to be a lot of water once you actually get to a fairly impervious site downtown. And we're asking you to control that on site usually. And this tool is supposed to help you do that. It's supposed to help you control the site, control that water, control that runoff, and treat some of it. So it's giving you the breakdown versus what you're going to have to treat versus what you're going to have to store and comparing to those targets. Tool also gives you, in terms of results, water balances. So here I've actually run 2 scenarios. I've got an existing scenario and a proposed scenario. And more often than not, actually almost every case I've worked in just about for the past 10 years for development, the Conservation Authority or the city has asked us to look at the water budget and match pre-existing infiltration to post-development infiltration. And you got to think that's pretty tough if you're paving over half your site. How are you going to get water back into the ground? But the thing is, there are a lot of users of water out there. We don't think about it much in Toronto, but there's lots of people who have wells. There's lots of people who need groundwater resources, and there's lots of natural environments that do rely on that groundwater discharge. So keeping that up is critically important. In this case, you can see we've built a site where we've increased the imperviousness. There's a lot less evaporation. That evaporation number has gone down. But the site infiltration has gone up because we've added some LID resources, and we've tried to get more water back into the ground to satisfy that requirement. And lastly, the tool is going to give you some loading input. So this is actually a specific request from the Lake Simcoe Region Conservation Authority. Anybody know where Lake Simcoe is? Show of hands. Who knows where Lake Simcoe is? Okay, this is the best result I've got so far today with the hands up thing. But yeah, so it's north of Toronto, and it's got a lot of land use around it as far as cities, got a lot of farms around it. So they have a problem with phosphorus in Lake Simcoe. Phosphorus is pretty high. So recently, Lake Simcoe Region put in something called the phosphorus offsetting program. So developers are now charged an amount at development based on how much phosphorus this is charged. And you see this one here, if you look at the left column here, 11.75 kilograms. Doesn't look like a lot. That's an annual loading for phosphorus. That 11.5 kilograms might cost the developer hundreds of thousands of dollars in development charges because they are really interested in how much phosphorus is going into that system, and the Conservation Authority is very strict about that. The way to bring that down, as we've done in this case here, is to start looking at low impact development, start looking at ways to treat that phosphorus to reduce the eutrophication of the Lake Simcoe region. And it's not a Lake Simcoe problem only. There are other places that are having the same phosphorus issues. But low impact development can bring that number down. And since you're saving the developer $100,000, they are very interested in seeing that number come down. So they want you to play around with different ways of treating it, different ways of reducing that phosphorus. And that's what the tool does. The tool is really designed to give you a quick way to evaluate different options. So you lay out your site, you try some different options for low impact development, try some different ways of treating things with traditional stormwater management, with infiltration system, the bioretention system, and seeing if you can get those numbers down to what people are looking for. And just playing around with that and getting the immediate feedback. That's really the goal of the tool, at that conceptual design phase, to get the immediate feedback on how your system might work. Then you go ahead and you proceed with detailed design based on that. So that's really where we're at. The tool is available now for download from either the STEP website or the Conservation Authorities. I'd really like it if you guys could try downloading this. I love to hear feedback, even if it's to tell me that the tool sucks or it has a problem or it's got a bug somewhere. We've had about 1,000 downloads so far since we released it last year. Some from outside Ontario, actually even some from outside Canada, which I found pretty interesting. Yeah, and so the conservation authorities have done a lot of workshops on this. They've gotten in front of people and run people through the tool basically to tell you this is how the tool is going to work. This is some example projects you can work through. And I've actually had clients come back to me. Clients have asked me, can you use this tool for my site? So it's nice it's become full circle. Now I'm seeing it from a different side. I'm having people asking me about this tool. And I'm excited about it. And more than that, the development team you saw before, they've actually had a lot of positive reviews from that. We're actually now at the point of doing a version 2 of this tool. So we've actually been hired again by the conservation authorities to go back and add some features to the tool. So deal with some of the feedback we've got, add some of the features we talked about before. And this is why it's good if you guys could kindly download this tool and give me some feedback, because we are trying to get some new things in the tool to help us out. So that's really it. I mean, the LED tool, based on what we've heard, has had a good impact. It's helped people add more low impact development design to their sites. It's helped educate engineers and scientists about how to design low impact development. It's helped encourage them to increase the amount of development on their site. The tool itself, as a means of communication, that's important too, seems to have a pretty positive impact. The idea that we're getting in front of people time and again, that we're seeing them over and over, we're getting their message across, and we're seeing more people pick up low impact development based on that. And so all of this, the LIDs, the software tool, the communication, I'm hoping this kind of resonates with you guys, and that this is something you guys can use in turn in your career. And I hope to be in the audience someday soon when your next nice idea becomes a reality. Thank you.